Hey everyone, this is Ayushi from Edureka, and in today's session we'll be learning Python for data science. Now Python for data science is definitely the next big thing in the industry and a must learn for professionals in the data analytics domain. So let us move forward and look at today's agenda. So we'll start this session by first understanding the need of data science, why there is sudden need of it, and then we'll understand what exactly is data science. After that, we'll understand why Python is preferred or used for data science over the other programming languages. Once we're done with that, we'll directly jump on to the hands-on part wherein I'll help you guys with data manipulation. That is how you can load data, analyze data, and perform some of its operations with different libraries of Python. After that, we'll understand and implement machine learning using Python. And finally, towards the end, I'll be doing a complete demo which includes various libraries, and using an algorithm of machine learning, we'll explore more about data. So I hope you guys are clear with the agenda. So let us begin with the very first topic, that is the need of data science. So traditionally, or you can say in earlier times, the data that we had was mostly structured and small in size, which could be analyzed by using the simple BI tools. But today, most of the data is unstructured, or you can say semi-structured. So by these terms, I mean the data is in unorganized format. And a lot of data is being generated, let's say from a multimedia, your text files, your sensors, and even from your instruments. So if you look at today's time, the data is actually getting created faster than we could ever imagine. So let's say you are traveling on road and you're using Google Maps for navigation. So there is a lot of data being captured through satellite and it is transmitted real time through your handheld devices. So this basically tells you whether the traffic is more or less in one locality, where exactly is the traffic jam, which road you should prefer, and all these things. So there is a huge amount of data which is generated. But the problem is we are not making correct use of this data. So earlier there were no decision making, no predictions were made about the data. More money was also spent, and hence we were not able to generate insights out of the data. But now what data science has enabled us to do is that we are moving from an approach wherein we have the data which tells us the situation or what exactly the situation was, and then how you can gain insights from that data. So now if you look at the image here, earlier we had only structured data which is in the organized form like DBMS or RDBMS or Oracle. But today we have both structured as well as unstructured data which is unorganized. So we need to deal with that as well. Then when this data grew a bigger, earlier we used to store it in the data warehouse where we had a concept of historical data and transaction data separately. So data warehouse is basically a large pool of databases. But today we have Hadoop. Now why? Because first of all, now we have tremendous amount of data which cannot be stored in a single secondary device. It has to be distributed. Multiple components should be there. It should be stored on cloud as well so that we can access it in faster ways. Then in traditional BI, it acts on data warehouse and it generates some reports or you can say graphics. That is nothing but your predetermined reports only. So month on month, we display same kind of reports and it does not go beyond that. But now what has happened, we apply various data science algorithms. We just not do simple reporting, but we also explore the data. We visualize the data and then we can build a story out of it. We can also perform some scientific discovery based on that data as well. So that is how data science has made our life so easy. Now let me give you one more example. So how about if you could understand the precise requirements of your customers from the existing data, let's say the customer's past browsing history or the purchase order or the purchase history, age, and let's say income as well. So no doubt you had all this data earlier too, but now with the vast amount and the variety of data that we have been receiving, you can train your model more effectively and recommend the products to the customer with more precision. Wouldn't it be amazing, guys, as it will bring more business to your organizations? So this is where the data science is actually needed. Now that you have understood the need of data science, let's understand what is data science. So data science is known as data-driven science, which makes use of scientific methods, processes, algorithms, and systems to gain insights by discovering some hidden patterns from your raw data. So data science has been primarily used to make decisions or predictions based on your data. Now, data science is being applied by the data scientist. So let me discuss the roles of data scientist as well. So first of all, data scientist is responsible for designing and creating processes for your complex as well as your large-scale data sets. So these data sets are basically used for your modeling, your data mining, and for your research purposes as well. So a data scientist is involved in processing your data, cleaning your data, verifying all the integrities of data for your analysis purpose. And all these things are done by data scientist. Also, the major role of a data scientist is to build predictive models using machine learning algorithms. So don't worry guys, we will be discussing all about machine learning in our further slides. But for now, I hope you got a basic understanding of what data science is all about. So let me discuss the life cycle of data, or what are the phases data actually goes from. So a data scientist provides a one-stop solution to all these operations. These operations are discovery, data preparation, model planning, model building, operationalize, and then communicating the results. So let us discuss all these operations one by one. So the first two steps are data discovery and data preparation. So in discovery, what you need to do, you first need to understand all the specifications of your data. You should also know the requirements, you should know the priorities and the required budget for the same. You should understand each and every aspect of data, where you know data is in which form, how much data is in string format, or how many numeric values are there, and all those things. Then what you do, you basically prepare your data, or the second step is data preparation. So in this, you basically ensure if there are any null values that has to be removed or replaced with some other dummy values, or if there are some of the data which is not relevant for your analysis. So that can also be removed. Further, you can also perform ETL, that is extraction, transform, and load. And so you need to explore, pre-process, and condition your data prior to your modeling part. So third is your model planning. So herein you will basically determine the methods and techniques to draw the relationship between the variables. So in this phase, you will basically identify the type of algorithm which you will be applying to data and then plan a model accordingly. So this was all about planning. Next, you actually have to build a model. So here you will develop data sets for training and testing purposes. So you will analyze various learning techniques like classification, association, and clustering to build your model. And finally, you operationalize the data, wherein you will deliver the final reports, briefings, codes, and all the technical documents. So once everything is done, you can then move it to the production. So what you need to do? So afterwards, just run the algorithm on the data and communicate the results to our end users. So what you're going to be communicating is that what are the insights you got from the data, what are the stories that you have found, what are the further predictions, what is the forecasting based on the data science that you have applied. So these are the steps which are there in any data science project. So if you pick up any project from any domain, these will be the steps it will go through. Next, we have different programming languages for data science. We have R programming language, we have SQL, we have Python, we have SAS, and we have many more like that. But here Python is the most preferred choice for data scientists among all of these. So let us understand why Python for data science. So Python has numerous features. So let me discuss one by one. So first of all, it is simple and it is easy to learn. So it's a very powerful language and it closely resembles your English language. Now furthermore, in Python, you don't have to deal with complex syntax like you used to do in Java or any other programming language. Next, it is fit for many platforms. So Python allows you to perform cross-language operations seamlessly. So Python is supported by most of the platforms ranging from your Windows, Linux, Macintosh, Solaris, and many more like these. Next, it is high-level and interpreted language. So by high level, I mean one does not need to bother about low level. You can simply write your code in English and Python will in turn convert it into low level details. Then it is interpreted, or you can say Python is a scripting language as well, which basically translates or runs your code one instruction at a time. It is also less code intensive as compared to any traditional programming language. Then you can perform data manipulation, analysis, and visualization with Python. So for manipulation, we use libraries such as NumPy and Pandas. So we'll be discussing these libraries as well. And for visualization, we have Matplotlib, Seaborn, and many more like these. But these are the most common ones that we use. And finally, Python comes with powerful libraries for machine learning applications and other scientific computations. So using Python, you can perform various machine learning algorithms with small and easy syntax, and you can gain insights based on the data. So this was all about Python and why you should actually use Python for data science. Next, moving ahead with Python, let's understand data manipulation. So data manipulation is where you can extract, filter, and transform your data quickly and efficiently. So data manipulation can be performed using libraries such as NumPy and Pandas in Python. So let us understand these two libraries one by one. So let us talk about NumPy first. So NumPy is the core library for scientific computing, which contains an array object, and it also provides tools for integrating your C, C++ as well. So what exactly is a NumPy array? Now NumPy array is a powerful n-dimensional array object which is in the form of rows and columns. So we can initialize NumPy arrays from nested Python list and access its elements. Now first what you need to do, you need to install this library. So for that it is very simple guys, you just need to go to your command prompt and type in conda install NumPy and your installation will be started. So in my case I am using Anaconda. So if you're not using that, you can simply go to command prompt and type in pip install NumPy. Now once the installation is completed, what you can do, you can go to your IDE, let's say your PyCharm, Jupyter, or anything. So in my case, I will be showing you all the practicals in Jupyter Notebook, and for that I am using Anaconda. So you can use it anything else as well. So once everything is done, what you need to do, just open your notebook. In your case, it can be any IDE, and type in import NumPy. And then you're ready to work with NumPy arrays. Similarly, we have Pandas. So Pandas is built on top of NumPy. So it is used for data manipulation as well as your analysis. Pandas is also well suited for different types of data such as your tabular data, your matrix data, then your observational or you can say statistical data, and many kind of heterogeneous data as well. So the installation process is exactly same as that of NumPy. You can go ahead and type in conda install pandas, and if you're not using Anaconda, you can simply use pip, and finally go to your IDE and type in import pandas. So let me open my Jupyter notebook and let's implement some of its operations. So I'll go to my PyCharm, I'll say Jupyter notebook. So this will take some time and it will open it in your default browser. So as you can see here, my default browser has been opened. So I'll just delete the previous ones. And as you can see here, my Jupyter is running fine. Now what I'll do, I'll go to new and I'll click on Python 3. So here, as you can see, this is my Jupyter notebook. So you can give any title to your notebook. So in my case, I'll say basic operations and I'll rename it. Now first let us discuss few things about NumPy. So I'll just make this as a header. So in Jupyter you just need to go to markdown and you can run this. So this NumPy is in my heading 1. Now I have to perform some of the basic operations. So as we have already discussed, Python stands for numerical Python. So Python can also be used as an efficient multi-dimensional container for your generic data. Now what exactly is multi-dimensional array? So let me just print a single dimension array as well as multi-dimensional array. So for that, first you need to import NumPy. So what I'll do, I type in import NumPy as np and I have just run this. So basically in Jupyter Notebook, to run this, you just need to click shift plus enter, or you can simply just click this button. So I have already imported NumPy, so this is not giving me any error. Next, what I need to do, I need to print a single dimensional array. Now for that, what I'll do, I type in a is equals to np, which stands for your NumPy, and then I'll type in array. And let's say I am giving some values, let's say 1, 2, 3, and then I'll print a. So I'll just click on shift plus enter just to run this. And if you see, my array has been printed. So this is my single dimension array. Now what if I want to print a multi-dimensional array, which is in the form of rows and columns? So what I'll do, you just need to go here, or let me just take another cell. I'll say a is equals to np.array. Here I'll say 1, 2, 3. And I'll put comma and I'll specify the columns as well. Let's say 4, 5, 6. And then I'll print the A and I'll say shift enter to run it. And as you can see here, I have a multi-dimensional array which is in the form of rows and columns. So I hope you got a basic difference between a single dimensional array and a multi-dimensional array. Next, let us perform some of the operations on these NumPy array. So let me just type in here NumPy operations. I'll make this code to markdown so that it will come in my heading. Even if you want to put in header 2, what you can do, you can specify one more hash and then you can just run it. So this is my header 1 and this is my header 2. So I hope you got the difference between header 1 and heading 2. Next, let us talk about some NumPy operations. So the first operation that I'm going to discuss is endem. So what this function do, it basically finds out the dimension of the array. So we have now just performed a multi-dimensional array. So what I'll do, I'll just copy this code over here and then in spite of printing a, what I'll do, I'll print the dimension of a. So we know that it's a multi-dimensional array. So let me just run this now. So as we have just seen here, it is a 2-dimensional array. So it is printing me 2. Next, what you can do, you can print the size as well. So I'll just copy the same example and I say the item size. So this will basically print me the size of each element present in the array. So let me just run this. So as you can see here, it occupies 4 bytes in the above NumPy array. Next, I want to know the data type of this NumPy operation. So what I'll do, I'll copy the same thing and I'll say D type. So this will basically tells me the data type of the array. So I'll just run this. So as you can see here, the data type of the array is integer and it is 32 bits. So I want to know the size and the shape of this array. So first of all, I'll print a.size. When I run this, I know that there are 6 elements. Then I also want to know the shape of this. So I'll say shape, a.shape. So it basically gives me the shape as well. Now let us move forward and see what are the other operations that you can perform with this NumPy module. So we can also perform reshaping as well as your slicing operation with this NumPy module. But first let us understand what exactly is reshaping and slicing. So reshape is when you change the number of rows and columns, which gives a new view to an object. So let me just take an example to explain this better. So let me first print this array. So I've printed this array. Now what I need to do for that, I just need to type in a.reshape, and I want it in the 3 rows by 2 columns. And if I run this, you can see the different guys. So these are my 3 rows and we have just 2 columns. So this is how you can reshape your NumPy array. So now let us go into the integrities of these array. Now what happens, let's say if you want to pick up just one element of a given array. So what you can do, you can simply type in here, let's say, I'll just copy the same thing. So let's say we have this array now. So what you want to do, you need a particular element. Let's say you want an element 3 out of this array. So what you're going to do, you're going to print a, and then you'll see specifying a0. And if I print this, it gives me the result 3. So what I've done, I've just specified my index and then the value I want. So this is my index. So here the array 1, 2, 3 is your index 0 and this is your index 1. So therefore we have printed the second element from the 0th element. So here this is my 0th element and I have printed the second element. So 0, 1 and 2. So I want the 3. So I have printed in my 0th index. I want the second integer, that is 0, 1, 2, and therefore it is printed 3. So taking one step forward, let's say we need the second element from the 0th element and the first index of the array. So let's say how you can perform this operation. So for that, what you can do, let me just copy this. So for that, what you can do, you can say A0, add a colon and then 2. So here colon represents all your rows including 0. So if you want to get the second element, we'll call the index 2 from both of the rows, which includes as the value 3 and 5 respectively. Sorry, it is not 5, it is 6 because the second element is my 6. So here as you can see, my second element from both the indexes has been printed. So here the colon represents your all rows including your 0th row. Next, just to remove the confusion, let's say we want one more row and we don't want to get its second element printed, just as the above example. So let me print that as well. Now I'll just change this example. I'll say 1, 2, 4, 5. I have 7. So now I'll print here. And if I run this, it gives me the value 2 and 5. So here what I have done, I have simply written 0 colon 2, which means that it does not include the second index of the third row of an array. So this will only print me 2 and 5 and not 7 and 5. So otherwise, if I have not written this colon 2, it will print me all the values as 2, 5, 7 and 5 again. So just by specifying colon 2, it will just not include the second index of the third row, or you can say the fourth row. Next, moving on, let's understand another operation, that is Linspace. So this is another operation in Python NumPy which basically returns all your even spaced numbers over a specified interval. So I'll just type in a is equals to np.linspace and I'll specify the numbers. Let's say 1, 3 and 10. And if I just run this, also haven't printed this, so let me just print that. So as you can see here, it has printed the 10 values between 1 to 3. So I've written 1, 3 and 10. So it will return me even spaced numbers between a specified interval. So I've specified an interval 1 to 3 and I want 10 numbers. So I have 1 something, 1.22, 1.44 and till 3. Then you can also find out the maximum, the minimum and the sum operations as well. So let me just type that as well. So I'll say a is equals to np.array. Now what I need to do, I need to print the minimum of these numbers. So I'll say a.min. Then I want the maximum as well. So I'll say a.max. And then I want the sum. So I'll say a.sum. And let me just run this. Alright, only the sum has been printed. So let me just do it individually. So I'll say, okay, the max is printed now. I'll say a.min, which is 1. Then I'll say a max and I'll just run this. So the maximum is 3. And if I just sum this, it will give me 6, which is 3 plus 2 plus 1, which is equal to 6. So that is how all these operations are very easy in NumPy. So you must be finding these pretty basic, but with the help of this knowledge, you can actually perform a lot bigger tasks as well. So let us understand the concept of axes in NumPy. So let me just print an array and let me tell you what exactly are axes. So I'll say numpy.array. So as you can see here, we have a NumPy array 2 by 3. So here the rows are called as axis 1 and all the columns are called as axis 0. So basically this is axis 0, which is all the columns, that is 1, 4, 2, 5 and 3, 6, and my rows are axis 1, that is 1, 2, 3 and 4, 5, 6. So now you must be wondering what is the use of these axes. Now suppose you want to calculate the sum of all the columns, then you make the use of these axes. So let me show you practically how you can implement this. So just you want to know the sum. Let's say I can type in a.sum and I'll specify the axis. Let's say I want the axis as 0. I'll say equal to here. If I run this, so it gives me the sum of this axis. That is 4 plus 1 is 5, then 2 plus 5 is 7 and 3 plus 6 is 9. That is how you got the sum of all the columns present. Similarly, you can repeat the task with axis 1 as well. Next, we have various other mathematical functions which you can perform with NumPy. So you can find out the square root, you can find out the standard deviation of the array. So let me just perform that as well. So I'll say, let me just copy the same array. And then I want the square root of it. So I'll say a dot square root. So I'll say np dot sqrt, which is for square root, and I'll then pass on the variable that is a. So I'll just run this. So as you can see here, the square root of all the elements are printed. So basically standard deviation means that how much each element varies from the mean value of the Python NumPy array. So that is how you can perform square root of it. You can also perform some basic operations such as addition, subtraction, multiplication and division of two matrices. So let me just do that as well. So first of all, I'll have two NumPy arrays. For that, I'll say x is equals to np.array. Then I'll initialize my second array, that is y. So I'll just copy paste the same thing. And now I have to print, let's say I want to print the sum of this. So I'll say print x plus y. And if I run this, you can see the addition has been performed on these NumPy arrays. Similarly, you can perform subtraction. You can perform multiplication. So multiply. So I'm getting this result. And you can perform other operations such as divisions and all. So next, if you want to concatenate two arrays and not just add them. So what you can do, you can perform it by two ways, either by vertical stacking and second is your horizontal stacking. So let me store it one by one. So I'll just create a header over here, that is my vertical stacking. Oh, I haven't changed the code to markdown. So I'll just mark down it. And I'll say it's my header 3. So I have done this and I'll just run this. So now I just need two arrays, so I'll just copy it from here and I'll show you how you can perform vertical stacking and horizontal stacking. That is concatenating two arrays and not just add them. So I'll type in here np.vertical stack and I'll pass in x and y. So I'll just print that. As you can see here, these arrays has been concatenated. Now I want it as in horizontal stacking. So I'll just remove v and I'll type in h over here. So I'll just run this. You can see it has been stacked horizontally. So guys, we have many more functions with NumPy, so you can just go ahead and practice more and more about it. So we have discussed NumPy. Now let us move ahead and understand some of the operations of Pandas library. So Pandas, as I've already told you, it is used for fast analysis, it is used for data cleaning, and it is used for data preparation as well. So let me go ahead and create a Jupyter notebook again and let's perform some of the basic operations there. So let me just name my notebook as Pandas operations. So we can perform various functions and operations on Pandas, such as we can create a series, we can create data frames, we can also calculate the missing data, and we can perform various other functions such as we can do merging with data, we can join some of the columns, we can join some data frames, we can concatenate, and we can perform various other functions with Pandas. So let me first go ahead and import Pandas. So I'll type in import Pandas as pd. So my import has been done. So I've just gone through my command prompt and typed in conda install pandas and my installation has been done. And after that I have come to my Jupyter notebook and I've typed in import pandas. So now what I'll do, I'll first create a list. So let me create a list, let's say lst, and I'll put in some values, let's say a. So let me create one more list, let's say list 2. And now I'll feed in some numeric values, let's say 1, 2, 3. Now first let us create a series in Panda. So for creating a series, what you can do, you can type in pd.series. You can just click on tab, which basically auto completes it. And inside the series, I can pass on my list. Let's say I'll pass my list 1. So if I run this, so this looks quite similar to your NumPy array. But the only difference is we have an index attached to the left hand side. So we have 0, 1, 2 here. You can also specify your index over here. So in spite of that, you can type in index. So I can basically pass down my second list. So I'll just copy this and I'll pass it over here. And now if I run this, you will see that first it was coming as 0, 1, 2, and now when I pass the second list, the index values has been changed to 1, 2, 3. Similarly, you can pass an array and dictionary or any other thing as well. So let me now pass an array to it. So for array, first what I need to do, I have to import NumPy. So I'll type in here import NumPy as np. Then I'll be creating an array, np.array, and I'll pass on one list. So let's say I'll pass on my list second. So I'll pass my array. So in spite of having ABC as output, I'll have the elements of list 2, which are 1, 2, and 3. So let me just run this. So here I've just passed the list 2 to both the arrays as well as the index. So I can just change my index to 1. So now you will see the difference. So here my list is ABC. So my index value is ABC, and my array, which has a list. So the list value contains 1, 2, 3. Similarly, you can pass on a dictionary, which contains basically the key value pairs. So this was just the basics of pandas. So pandas can hold a variety of data objects. So you can pass in anything to it. Now let me perform some of the operations with pandas. So let me type in here operations, and I'll say as markdown. Let's say I want the heading 1 only. So now what I'll do, I'll perform an operation with the list as well as a series. So what I'll do, I'll first print a list. So let me just create a list. Let's say list is equals to A, B, and C. So let me just print this list as well. So here my list is ABC. Now what I'll do, I'll create a variable which contains this list. So I'll say list variable, and inside this I'll pass a function, let's say list multiply by 2. So now if I print this, let me just first print this. So here as you can see, I have my list as ABC, and if I multiply it by 2, the same list has been repeated again. So with series, you have to basically square the values. Now let me implement that as well. So what I'll do, I'll create a series. So I'll say series is equals to pd.series, and inside series I can pass on the list. So let me now first print the series. So here as you can see, I have my series with an index value of 0, 1, 2. So now I'll print the same function which we have done with the list. So I'll create here a series variable. Inside that I'll say series multiplied by 2. And if I print this variable, let's see what does it give me. So as you can see here, so it will basically square up the value. So here I was having ABC, and now I have AA, BB, and CC. Whereas in list I was just getting these 3 numbers duplicated. So this is the main difference between a list and a series. So you can perform any other operation with series. You can have 2 series, you can add them at. So let me just create that as well. So I'll have series, let's say s1.pd.series, and inside that I can pass on, let's say 1, 2, and my columns can be, let's say I'll take the example of subjects, let's say maths, then I have English, and let's say then I have Hindi. So now let me just print this series 1. Alright, so I have just given 2 rows, so I'll be giving 2 columns only. So I'll just run this. Alright, so this is done. Similarly, I'll create one more series. So I'll just copy this. I'll be creating another series. So I'll be giving the name S2. I'll be printing it. And in spite of the subjects, I can change it. Let's say I want to change it to Hindi. Alright. So now let me just print S2 as well. So here as you can see, my both of the series have been printed. Now what I want to do, I want to perform an addition operation on both of the series. So I'll say S1 plus S2. So if I run this, so now as you can see here, my maths has been calculated 2.0, and my English and Hindi does not contain any value, which is NaN. So as you can see here, my maths has been calculated 2, and English and Hindi doesn't find any math, so it will return me NaN. So therefore pandas hold a variety of data objects. And if you have noticed, Panda automatically converts your integer value to float. Since we are getting maths twice, so we haven't got the output as integer. It automatically converts it to float. Now why does it? It basically do it because to retain all the information which is possible. So similarly, you can perform various other operations with pandas. Now let us see some of the operations with data frames. So I'll say data frames. So this is my header 2. Now, what exactly is a data frame in pandas? So data frame is nothing but it is a panda series which shares the indexes. So for that, let me just import NumPy and pandas. So import NumPy as NP and import pandas as PD. So next what I'll be doing, I'll be importing one more module which is numpy.random. So this I'll be telling you in a bit. Alright, I've done some mistake. So it is import random. So my input has been done successfully. So now what I'll do, I'll first have np.random.seed and inside that I'll say a number, let's say 101. So this basically ensures that we get some random numbers. And that is why we have imported this module as random. Now what I'll do, I'll create a data frame. So for that I'll say df.pd.dataframe. I can just click on tab and it will show me the suggestion. And inside that I can pass on the function that is rand and I'll pass which matrix I want. I want 3 by 3 matrix. So I'll be having 3 rows and 3 columns. So now I have to specify those 3 rows and columns. So I'll be typing in, let's say A, B and C. So now let me just print my data frame. So as you can see here, I have a beautiful data frame with some random values in it. So data frame is nothing but it is a bunch of series which is sharing the indexes. So here we have a series with a column name of D. Then we have a series of column name E and similarly we have for F. So now if you want to print a single series, let's say I want to grab a series of column D. So for that what I can do, I can type in df and I can specify the column. Let's say I only want to know the series which is in the column D. So if I run this, alright, so I forgot to mention the square braces over here. So here this series has been printed which is 2.70, 0.5 and minus 0.84. Similarly, I can have it for E row, E column. So here this series has been printed. Now what if I want to confirm whether it is a series or not? So for that what I can do, I can simply ask for the type. So what I'll do, I'll say type data frame and inside this I want to know whether it is a series or it's something else. So if I run this, so it basically tells me that it is a panda series. Similarly, I can know the type of anything else. Let's say I want to know the type of df, which is a data frame. So let me just run this. So here it tells me that pandas data frame. Now you can perform various other operations on this random numbers or you can say the data frame that we have just created. So now let me just print the first 2 rows of this data frame. So for that I'll do df.head. So this is a function which basically prints the value. So here I want just 2 rows, that is A and B. So I'll say 2 and if I run this, so as you can see here, I got the 2 rows of the entire data frame. Now let's say I have just printed head over here. Now I want the last row. So for that what I can do, I can say df.tail and I can say 1. So I'll just need the last row. So if I click on run, I'm getting the C row which is the last row. Next, you can also perform various other functions such as merging, joining, concatenation of 2 data frames and all these things. So now let me perform one more operation of data manipulation, that is data cleaning, or you can say there is any null value in your data frame. So what I'll do, I'll type in df.null and I'll say any. So it will basically tells me that if my data frame contains any null value. So here we can see that it does not contain any null value. So let me just print it. Alright, so it is null. So as you can see here, I have D column which is false. So it does not contain any null value. In fact, we have already provided with some random numbers. So there is some null value, so it will give me a true value over here. Similarly, you can perform one more operation, that is you can basically drop a column. So let's say I want to drop one column or if you want to drop a row. So what I'll do, I'll type in df.drop and inside that I can mention any other row. Let's say I want to drop the row C. So if I run this now, my data frame does not include the row C. So that is how you can perform various operations on series, on data frame, on arrays or anything. So you can perform a lot more things with that. Also with manipulation with pandas and numpy, you can clean your data. So just like I have done it here, I have dropped one table. I have checked whether it contains a null value or not. You can basically separate your relevant arrays out of your data frame. Then you can separate Then you can just separate the delimiters. You can also convert your series to strings or string to series. Then you can handle the missing values. You can also detect outliers, and you can do many more things with pandas. So if you want to know more about this panda series, you can go to their official website and you can learn all the examples. So just guys, practice more and more of these two libraries and you will be perfect in these. Next, let me go back to my presentation and let's see what is my next topic. So we have discussed various operations on NumPy as well as pandas, and hence you'll be able to manipulate the data according to your needs. But again guys, I'm saying I've just showed you the basic operations. You can go ahead and you can perform many more with it. Now let us move on to a next topic, that is machine learning. So machine learning is the type of artificial intelligence that allows the software application to learn on its own. So basically what happens, from quite a long time we are creating a machine or a program that follows a set of instructions. So what do? We basically frame a set of instructions or rules which will be followed by the program. But our brain does not work in this fashion. So it learns how to behave in different scenarios on its own. And how does it do that? It learns through the experience. So this is the main idea behind the machine learning, that is to mimic the way our brain works. So what we do in machine learning, we create systems or programs that learn how to behave when exposed to a new data set. So how can we achieve this? So what we do, we allow machine learning to detect patterns in data set and create models out of it. So and later on we can adjust that model according to our needs and enhance the accuracy of the model. So if you look at the image here, so what you do, you first train your data, and based on any machine learning algorithm which is built on your data set, you build a model. And there if you see, there is this feedback loop going on which is performed again and again until we achieve a good amount of accuracy. So this is the whole idea behind machine learning and how machine learning works. Also machine learning can be used in various other domains such as in analytics, in weather forecasting. It is used for, let's say, what will be the stock price next day, and all of this thing can be done using machine learning, where the system is learning by its own or detecting patterns so that it can take actions when it is exposed to a new data set. So now let us move on to different types of machine learning, or you can say the different categories of machine learning. So it is basically classified into three types, that is supervised learning, unsupervised learning, and reinforcement learning. So let's talk about all these three, taking one at a time. So let's start with supervised learning. So supervised learning is where you have an input variable x and an output variable y, and you use an algorithm to reduce the mapping function from the input to the output. So as you can see here, we have a function which is y is equals to fx. So basically you have to figure out this function fx. So the idea behind supervised learning is fairly simple. You have a set of inputs. Let's say for example we have a value, let's say x is equals to 1, 2 and 3. And similarly we have a value of y which is equals to 2, 4, let's say, and 8. So here what we need to do, we need to figure out the mapping between the two, which is 2 to the power n. So here we have reduced the function, that is 2 to the power n. So once this very function is identified, or once we know the mapping, what we can do for any new number or for any new data or any new input, let's say we have a new input of 4. So we can predict the outcome, or you can say the y value. So here in our case, the value would be 2 to the power 4, which is equals to 16. So here we know the mapping function, which is 2 to the power n, and from that we have reduced the value of y, that is 16. So I hope you got the fundamental of supervised learning. Now the reason why it is called supervised learning, it is the process of the learning from a training data set. So the whole process to figure out the mapping function can be thought as a teacher supervising the learning process. So for example, a teacher teaches a topic to a bunch of students. Now if the student understands that topic thoroughly, even if any new problem comes or any new problem arises to the student related to the same topic, the student can go ahead and solve the problem or take the necessary action for the same. So this is the whole idea behind supervised learning. Next, supervised learning contains various algorithms such as your linear regression, logistic regression, decision tree, random forest, and naive-bayes classifier. So all these algorithms can be used for different use cases. So in case of linear regression, it is used to estimate real values such as cost of house, or number of cells, or number of calls, or total number of sales based on the continuous variables. Whereas in logistic regression, we estimate discrete values, that are the binary values such as 0, 1, yes or no, true or false, based on set of independent variables. So don't worry guys, I'll be implementing this practically as well, but let me just give you a basic introduction of all these algorithms, and then we can proceed with the practical, wherein I'll be implementing logistic regression. So then comes the decision tree. So decision tree is basically used for classification problems. Whenever you want to classify your data set in different categories, we use decision tree. And this works for both categorical and dependent variables. So don't worry guys, we will understand this dependent variable, independent variable, or the other key terms that I keep on using. During the practical, I will explain everything to you. But for now, you can just understand as dependent variables as your output, whereas your independent variable as your input, that is your X. So next we have random forest. Random forest is quite similar to a decision tree, but it gives better prediction and accuracy than decision tree. And last we have naive Bayes classifier. So this is based on Bayes theorem, wherein you have no relation between different predictors so as to predict our output. So this was all about supervised learning. Now let me just implement, let's say, a logistic regression, and let's say how can you apply machine learning to it. So now let's understand what exactly is logistic regression. So logistic regression, it basically produces the results in a binary format. So we have already established this fact that the outputs would be yes or no, it can be true, false, high, low, pass and fail, and all these things. So basically it should be categorical. It should be only either yes or either no. So therefore it predicts the outcome of a categorical dependent variable. So whenever you apply your logistic regression, you should be very precise about which are your dependent variable and which are your independent variable. So let us first understand the relation between independent variables and dependent variables. So I hope all of you must have come across this equation, which is the equation of a straight line, that is y is equals to a plus bx, wherein we have y as dependent variable, x as independent variable, a is the y-intercept and b is the slope. So here the dependent variable is basically the unknown value of a variable or the value which needs to be predicted. Then we have x, which is independent variable, that is also known as known variable, or the variable which is related to the dependent variable. So this dependent variable will be dependent on the independent variable. Next we have a, which is the y-intercept. So this is the value of dependent variable when the independent variable is 0, or the point at which the line cuts the y-axis. So that is why it has been given the name, that is y-intercept. And then we have b, which is the slope, which is nothing but the change in dependent variable for a unit increase in the independent variable. So it is also known as the tangent of the angle made by the line with the x-axis. So now let us implement this logistic regression. So here I have a problem statement wherein a car company has released a new SUV in the market. And using the previous data about the sales of their SUVs, they want to predict the category of people who might be interested in buying this. So here I have a data set which includes user ID, it has gender, it has the age, it has the estimated salary, and whether the people can purchase the SUV or not based on the salary or based on any other factor. So I'll be telling that what are the dependent variables over here and what are the independent variables. So let me just go to my Jupyter and let us implement logistic regression. So herein I'll create a new file, or you can say the new notebook. So let me just name this as demo. So here I want the header, let's say logistic. So here first of all we need a library which is scikit-learn. So this is a library which is used to perform machine learning in Python. So scikit-learn is nothing but it is an open source library which is licensed under BSD and it provides a range of supervised and unsupervised learning algorithms in Python. So scikit-learn consists popular algorithms and libraries, and apart from this it also contains the packages such as NumPy, Matplotlib, SciPy, which is also called as scientific Python. So remember guys, to import scikit-learn you first need to import all the packages such as NumPy, Matplotlib and SciPy. So we already talked about NumPy and Pandas. So we'll be importing scikit-learn as well as Matplotlib. So how you can do that? You can simply go to a command prompt and type in conda install scikit-learn, or you can say conda install matplotlib. And if you're not using Anaconda, you can go to a command prompt and type in using the pip command. So let me just import all these libraries. Let's say first I'll import NumPy. So you know how it is done. So I'll say import NumPy as np. Then I have to import pandas. Then I'll be importing one more library, that is Matplotlib. So this is a visualization library which is used for 2D graphics. So I'll say import matplotlib.pyplot as plt. And for Matplotlib in Jupyter you have to type in %matplotlib inline. So let me just run this. Alright, so my import has been done successfully. So now what you need to do, the first step would be importing your data set and separating the dependent variable as well as the independent variables. So first let me just import my data set. So I'll be needing pandas for it. So I'll type in pd.read csv. So my data set is in the CSV format, and then I'll mention the name of my data set. That is the car purchasal estimation .csv. So now let me just print this data set. So as you have already seen in the presentation, I have a user ID, I have gender, I have age, estimated salary, and purchase. So almost I have around 400 rows and I have 5 columns. So now what you need to do, you first need to identify which are your dependent variable and which is your independent variable. So in our case, a dependent variable is purchased and an independent variable is age and salary. So this is my unknown value and this is the value we have already. So we have the salary and we have the estimated age and we have a dependent variable which is purchase. So now let me just specify my dependent variable as well as independent variable. So I'll go ahead, I'll type in here capital X and I'll say dataset.iloc. So here I'll specify my rows and columns. So I'll be taking all the rows. So here I'll be taking just second and third column, which are my age and estimated salary. So these are my independent variables. So I have specified over here that X is my independent variable wherein I have all the rows and I have second and third column as independent variables. So now what is this iloc function? So iloc function is an indexer for Pandas data frame and is used for integer based indexing, or you can say the selection by position. So I have taken the columns 2 and 3, which is my age and the estimated salary based on the index position. So now let me specify my dependent variable as well. So I'll say y is equals to iloc and I'll specify all the rows and I just want the fourth column, that is the purchased column. So this is my dependent variable and I'll just take the value of it. So I'll say values. Now let me just print X. Alright, so I have just done a stupid mistake. I have just forgotten A. Now it should print. So here as you can see, I have both my independent variable, which is the age and the salary. Similarly, I can print Y as well. So I'll print in Y, which is the value of purchased. So here it's the value of purchased. So this is basically the last column which we need to input, that is the purchased, or you can say the fourth column. So the next step would be training and testing the data. So here you will be splitting the data into two subsets, that is your training subset and your testing subset. So for that, what you need to do, you need to import cross validation. So here I'll type in from sklearn.cross-validation and import train test split. Alright, it's an underscore over here. Alright, so this is done now. So now what you need to do, you have to define the variables for your train subset and your test subset. So what I'll be doing, I'll be writing x train, then I'll be writing x test, and similarly for y variable, that is y train and y test. And then using this function train test split, I'll be passing in x variable, that is the independent and dependent variable, and then I'll mention a size to it. Let's say test size is equals to 0.25. So I'll just explain this in a minute and I'll specify a random state. Let's say you can put in any value. So in my case, let's say I'm putting 0. So this will basically ensure me that the same sample has been taken every time whenever you run the code. That is why you mentioned the random state is 0. Now what is this test size? So here we have basically split the training and testing subset in 0.25%. Now what I need to do next, we need to scale the input values for better performance. Now how you can do that? You can use a standard scaler for that. So for that, what we'll be doing, we'll be typing from sklearn, that is the machine learning library, and we'll be using preprocessing, and here I'll be importing standard scaler. Alright, so why do we basically scale our input values? So if you see a data set, we are dealing with large numbers. Although it is a very small data set, so whenever you'll be working with a production environment, you will be seeing large data sets where you will be having 10,000 or 100,000 of tuples. So there scaling down the input values can definitely affect the performance of the whole program to a high extent. So for that, we need to scale our input values, and in Python we need to import standard scaler for that. So then we have used something called as preprocessing. So preprocessing basically contains all your methods, or you can say functionality, which is required for transforming your data, or you can say feeding your data to a model. So now let me just scale down the input value of test data as well as your training subset. So I'll be writing in here sc.standard scaler, then xtrain, and here I'll be passing in the variable that is xtrain. And similarly for xtest subset, and here also I'll pass the test subset. Alright, so here I have just typed in the same line in this cell. This is running. Now what we need to do, we have to create a logistic regression model. So first of all, I'll be importing logistic regression. So I'll type in from scikitlearn linear model import logistic regression. Alright, now what you need to do, you need to feed data into model. So I'll be using classifier. So here I'll be typing in classifier logistic regression, and I'll specify a random state, let's say 0. Now I'll just fit this model classifier.fit, and inside this I'll be passing xtrain and ytrain. So I'll be saying xtrain and ytrain. So now we can use this and predict the results of a test set. So now instead of printing the value of predicted outcome and your actual dependent value, what you will use, you can use something called as confusion matrix. So confusion matrix is nothing but it is a 2 by 2 matrix wherein you have columns which has a predicted no and a predicted y, and rows have actual no and an actual yes. So let me just show you the concept of confusion matrix. So first you need to import this confusion matrix. So for that you need to type in from scikitlearn.metrics import confusion matrix. Alright, there is a spelling mistake. Now what I'll be doing, I'll be creating a variable cm which has the confusion matrix of y values, which is the y test and the y predict. So I'll type in y test and y predict. So now I'll be printing a confusion matrix. So here it is giving me that it is y test is not defined. So oops, I just forgot to mention it over here. So here I'll be using this y predict to predict the results of your test data set. So I'll be typing in y predict, and I'll be saying classifier dot predict, and I'll pass on the x text. Alright, so y is in my capital. So it's saying that y test is not defined. So if I go ahead, alright, because y is in the uppercase, so I'll just copy paste the same, and now let me just run this. So here my confusion matrix has been printed. Now let us understand the concept of this confusion matrix. So as I've already explained you that confusion matrix is a 2 by 2 matrix and we have 4 outcomes to it. So let me just explain that to you. So here in the columns we have predicted no and predicted yes. Whereas in rows we have actual no and we have actual yes. So here let me just copy the same values over here. So here we have 65, that I'll just write it over here. Then we have 3, then we have 8, and we have 24. So as you can see here, the two fields which is 65 and 24. So this is basically my actual no and predicted no, and actual yes and predicted yes. It basically refers to the predictions which were correct. Now these fields which is 8 and 3. So these are the fields where the model predicted yes, but in reality the output was no. So there were 8 cases which were predicted no, and actually on the data set it was yes. So this is also known as true negative. It is known as false positive. This is known as true positive, and this is called as false negative. So to calculate the accuracy here, what you need to do, you need to add the true negative and true positive and divide it by the total sum. So what you need to do, so here 65 plus 24 is equals to 89, and the sum which is 65 plus 3 plus 8 plus 24 is your 100. So basically we are getting the accuracy as 0.89. So therefore we are getting the accuracy as 89%. So here we have done this manually, but in Python we have a function for this as well. So basically our machine will calculate the same for us. So you can go ahead and import accuracy score, and then you will be getting the same result as that we have calculated. So here we have implemented logistic regression with the accuracy of 89%. So now let me go back to my presentation and let's see what else we have. So I just first cleared this up. Alright. So we have understood what exactly is a logistic regression. Now let us move ahead and understand the second type, which is the unsupervised learning. So using unsupervised learning, we can train our model based on the unlabeled dataset. So in an unlabeled dataset, there is no explanation or tags with respect to each piece of data. It just contains your data and nothing else. So one of the examples of unlabeled data can be an unlabeled photo or an audio which is scraped or grabbed from internet. So now, if you remember, when we have talked about supervised learning, we were dealing with those data sets where set of input and set of outputs were clearly defined or clearly specified. But we cannot apply supervised learning in these cases where the data is not defined or it has not been labeled properly. So unsupervised learning basically draws inferences from datasets or unlabeled datasets on its own. Therefore, we can use this model so as to cluster the input data into classes on the basis of various statistical properties. So we have various algorithms in unsupervised learning such as k-means clustering, hierarchical clustering, and many more. So we'll not be doing the practical of unsupervised learning in this session. So I'll just be briefing you with the types of machine learning algorithms, and later we will come up with series on these individual algorithms. So with the advanced part of machine learning, we have next session lined up. So I don't want you guys to miss any of those sessions. So this was all about unsupervised learning, and the third type of machine learning is your reinforcement learning. So reinforcement learning basically is when your computer tries to take decision on its own rather than being taught explicitly. So computer's aim is to maximize reward when it does an action. So for example, you ask a child to complete his homework by evening, and if it does that, you'll give a reward to them, or let's say a chocolate to them, and then the child will automatically do it. So what happens, the child will keep on repeating so as to get more chocolates. And finally, he understands from the past experiences that, okay, when I did this, I got an award. So let me just do something similar, I'll get more rewards. So that is the whole idea behind reinforcement learning. Now again, there are numerous algorithms in reinforcement learning such as Q-learning, then we have SARSA, then we have DQN, which is related to deep learning, and we have many more like that. So we'll be discussing all the use cases in our further sessions. So that is it for today, guys. So let me just recap what we have started so far. So first of all, we have started what is the need of data science, why exactly data science came into the picture. Then we have understood what is data science, the life cycle of data. After that, we have figured out why Python is best for data science and its various other features. So once we have established that fact that Python is best for data science, we have gone ahead and we have performed some of the data manipulation wherein I have explained you how we can load the data, how we can perform some of the basic operations with NumPy and Pandas. Then what we have done, we have took an overview of machine learning wherein I have explained you the concept of machine learning and the different types of it. So we have discussed about supervised learning, we have discussed unsupervised learning and a reinforcement learning. And finally in the demo part, I have explained an algorithm of supervised learning, that is a logistic regression, wherein I have implemented all the libraries that we have studied so far and how you can apply a machine learning to it. So in that demo, we have first imported the libraries, then we have understood what are dependent variables and independent variables. Then we have also split the dataset into training dataset and validating dataset. Then what we have done, we have trained a model, or you can say create a model. And finally, we have predicted the output based on the test dataset. So that is it for today, guys. So I hope you like this session. So next, if you have any doubts or any queries related to any of the topics that I have discussed so far, you can comment below the video and I'll be happy to help you with the same. So that's it, guys. I hope you have a great day. Thank you. Bye bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!